Hello everyone. Welcome to SHR Trinity. In our previous video, we explored zero-shot prompting. Today, we advance to the next critical technique, few-shot prompting. In this video, we will cover the foundational interview questions on few-shot prompting, explaining how providing just a single example can drastically improve a model's accuracy and format adherence. Let's get started. Before we begin, if you're looking for practical, industry-oriented training in artificial intelligence and generative AI, SHR Trinity offers a comprehensive 30-hour training program. For complete course details, check the description below. Now let's begin today's interview session. We will now begin with the interview questions for few-shot prompting, Part 2, Intermediate Strategies. Question 1. How does the order of examples affect a few-shot model's output distribution?
The order of examples in a few-shot prompt significantly impacts model predictions due to attention allocation shifts. Reordering the exact same set of examples can alter output accuracy by as much as 20% to 30%. To explain this simply, transformers experience positional bias where earlier and later examples exert stronger influence than middle examples. If difficult or ambiguous examples are placed at the end, the model may over-index on them. For example, in real-world scenarios, testing example order ABC versus CBA on an intent classification dataset and observing a 22% shift in overall classification accuracy. A common mistake to avoid is assuming that example order is irrelevant and placing examples arbitrarily without running permutation tests. As a tip for your interview, advise running combinatorial order permutations during prompt benchmarking to discover the optimal example sequence.
Question 2. What is majority label bias and how do you mitigate it in classification tasks?
Majority label bias occurs when an LLM systematically favors the class label that appears most frequently in the few-shot prompt examples, distorting the model's posterior probability distribution. To explain this simply, if a prompt contains 4 positive examples and 1 negative example, the model learns an artificial prior probability favoring positive responses, leading to severe misclassification of negative inputs. For example, in real-world scenarios, a 5-shot prompt with 4 spam examples and 1 not spam example incorrectly classifying legitimate customer emails as spam. A common mistake to avoid is failing to maintain a strictly balanced 1-to-1 ratio of class representations in multi-class few-shot prompts. As a tip for your interview, always balance example counts equally across all target classes to eliminate majority label bias.
Question 3. How do you select the most representative few-shot examples for domain-specific tasks?
To select optimal examples, choose inputs that reflect real-world data variants, cover expected edge cases, and use domain-specific terminology matching the production environment. To explain this simply, generic examples fail to condition the model on specialized domain rules. In healthcare or financial applications, examples must contain domain jargon, acronyms, and formatting standards. For example, in real-world scenarios, using clinical discharge summaries with medical abbreviations, e.g., point presenting with SOB and HTN, rather than generic conversational text. A common mistake to avoid is using toy examples from public tutorials when building prompts for specialized medical or legal NLP pipelines. As a tip for your interview, select examples based on semantic closeness and structural fidelity to actual production queries.
Question 4. What is dynamic few-shot prompting and how is it implemented with vector databases?
Dynamic few-shot prompting is a technique where few-shot examples are dynamically retrieved from a vector database at runtime based on semantic similarity to the incoming user query. To explain this simply, instead of hard-coding static examples into the system prompt, the user query is converted into an embedding. A KNN search retrieves the 3 most semantically relevant historical examples to construct a custom prompt on the fly. For example, in real-world scenarios, using LangChain's semantic similarity example selector paired with Face or ChromaDB to fetch relevant support ticket examples dynamically. A common mistake to avoid is hard-coding a static set of 5 examples for a system that must handle thousands of distinct user intents. As a tip for your interview, explain that dynamic few-shot prompting combines retrieval augmented generation, RAG, with prompt engineering.
Question 5. How does few-shot performance scale across different LLM parameter sizes?
Few-shot learning performance exhibits strong emergent scaling properties. Larger parameter models, e.g., 7 dB plus parameters, utilize few-shot examples far more effectively than smaller models, e.g., 7B parameters. To explain this simply, smaller models often lack the parameter capacity in their attention heads to perform complex in-context pattern matching, whereas large models rapidly adapt to nuanced formatting and logic in few-shot prompts. For example, in real-world scenarios, a 7B parameter model struggling to follow a complex 3-shot JSON schema, while a 7dB parameter model follows it with 99% fidelity. A common mistake to avoid is expecting a lightweight 3B parameter edge model to perform complex few-shot reasoning without prior fine-tuning. As a tip for your interview, recommend fine-tuning or specialized instruction tuning when deploying small parameter models.
Question 6. Can few-shot prompting teach an LLM step-by-step reasoning using chain of thought?
Yes, by incorporating step-by-step reasoning steps into the example outputs, known as few-shot chain of thought, COT, prompting, LLM reasoning accuracy on math and logic tasks increases dramatically. To explain this simply, when examples demonstrate explicitly how to break a problem down into intermediate logical steps, the model mimics that reasoning trajectory before generating its final answer. For example, in real-world scenarios, example output, let's break this down. Step 1, calculate tax, 10% of $50 equals $5. Step 2, add to total, $50 plus $5 equals $55. Final answer, $55. A common mistake to avoid is providing complex multi-step math problems in the task while only giving direct, one-word final answers in the few-shot examples. As a tip for your interview, highlight few-shot COT as the single most effective method for boosting reasoning performance on complex tasks.
Question 7. What is the impact of incorrect semantic labels versus incorrect formatting in examples?
Research demonstrates that LLMs learn output formatting and syntax far more strongly from few-shot examples than the actual correctness of semantic labels. To explain this simply, even if few-shot examples contain randomly flipped labels, the model can often maintain reasonable task accuracy as long as the structural format, e.g., JSON schema, remains clean and consistent. For example, in real-world scenarios, a prompt where sentiment labels are intentionally swapped still teaches the model to output valid JSON objects matching the schema. A common mistake to avoid is assuming that a model failing on a task is caused by bad logic when it is actually caused by inconsistent example formatting. As a tip for your interview, state that example formatting governs syntax adherence, while label correctness governs semantic accuracy.
Question 8. How do you handle long input texts in few-shot prompting to preserve context length?
To handle long inputs, use concise, summarized examples that capture the structural transform without consuming excessive prompt context tokens. To explain this simply, few-shot examples do not need to mirror full multi-page documents, they only need to represent the essential input-output mapping pattern. For example, in real-world scenarios, truncating 1,000-word article examples down to 50-word key passages while preserving the exact summary output structure. A common mistake to avoid is including full-length enterprise documents in few-shot examples, exhausting 80% of the model's context window. As a tip for your interview, optimize examples for maximum token density, conveying maximum structural pattern in minimum token length.
Question 9. What is overfitting in few-shot prompting and how do you avoid entity copying?
Few-shot overfitting occurs when the LLM accidentally copies specific words, names, or entities from the example text into its output for the actual user query. To explain this simply, if all few-shot examples feature a character named Alice, the model's attention mechanism assigns high probability to generating Alice in response to new queries. For example, in real-world scenarios, a customer service bot responding to user Bob by calling him Alice because all prompt examples used the name Alice. A common mistake to avoid is using repetitive, static entity names across all few-shot examples in a prompt template. As a tip for your interview, use diverse, synthetic, or generalized placeholders across few-shot examples to prevent entity copying.
Question 10. Why are explicit structural delimiters essential when nesting few-shot examples?
Structural delimiters create unambiguous token boundaries, allowing the LLM's attention mechanism to isolate individual examples and differentiate them from the target query. To explain this simply, without delimiters, attention heads blend the end of example 1 with the start of example 2, leading to corrupted outputs and hallucinated responses. For example, in real-world scenarios, wrapping each example in explicit XML tags, example_1, /example_1, example_2, /example_2, user_query, /user_query. A common mistake to avoid is relying on simple line breaks between examples, which LLMs can mistake for internal paragraph breaks within an example. As a tip for your interview, standardize on XML or Markdown block delimiters for production-grade prompt templates.
Excellent. You've completed few-shot prompting, Part 2, Intermediate Strategies. In the next video, we'll dive deeper into using one-shot prompting to enforce strict JSON and XML outputs for API integrations. If you found this video helpful, please like, share, subscribe to SHR Trinity, and press the notification bell so you never miss our upcoming AI interview preparation videos. Thank you for watching. See you in the next video.